Good morning and welcome, students. I hope you're staying out of the rain and being safe. I didn't want to waste the instructional time that we have, so what I'm going to do is I'm going to record a video lecture along with the PowerPoint so that you can look at it at your leisure, and then by Thursday we can move on to the next chapter. So today what we're dealing with is the scientific revolution and the origins of the scientific revolution, where it developed a collaboration between artists, artisans, and intellectuals, building machines for practical purposes, laws of perspective and optics, and alchemy and astrology. And that's particularly interesting because alchemy is where you change lead into gold. You can't do it. Astrology is a study of the stars and where people, how they line up. It's not really a science per se, but it's more of a mystic tool, but it became very popular in the 17th century. Now, another thing that led to the scientific revolution were voyages of discovery where travelers' accounts of foreign lands, like Marco Polo, would come back and then attacking the authority of the ancients. Now, what we're going to see is it's going to be a conflict between the Roman Catholic Church and science, because science was dealing with a heliocentric universe and religion was dealing with a geocentric universe. Now, heliocentric means sun-centered. Geocentric means earth-centered. A lot of the higher-up officials in the Catholic Church believed that the earth was the be-all to end-all and that it was perfect because God created it. But scientists were going to prove them wrong. There was a Copernican revolution named after Nicholas Copernicus. He was an astronomer. And he challenged the authority of Aristotle and Ptolemy, where he basically said the heavenly bodies orbit in a hierarchical spheres, which is the circles around the sun. The heavens and the earth composed of different matter, and the quintessence, the ether, the intoxication of understanding how science works. Earth, air, fire, and water, and that perhaps there may not have been a God, but a prime mover rather than an all-seeing type of omnipotent personality. In the late Middle Ages, the Ptolemaic system did not conform to observations. Now, the Ptolemaic system was a little bit more belief in the mystical, not using mathematics or physics or anything of that nature. Retrograde motion. The Roman calendar was out of alignment with the movement of heavenly bodies, and there was a problem with Easter, and other holy days when it comes to the Catholic Church conflicting with science and that basic type of calendar. Now, Nicholas Copernicus was born in 1473 and he died in 1543, and he's a Renaissance man. When we use that term today, we mean a jack of all trades and a master of none. He was very classical. In his system, the Earth moved and was not the center of the planetary system. Now, this was revolutionary because of the simple fact that the Church did not agree with it. The Earth rotated on its axis, and orbited the Sun. Now, when we look at particular instruments of that day, here's an astrological instrument from Ptolemaic, where he believed that everything revolved around the Earth. Not a bad type of assumption. However, Copernicus and other later astronomers would prove this to be wrong. The Copernicus revolution under Nicholas Copernicus believed he had restored a pure understanding of God's plan, but was troubled by its implications, basically science and religion. There were new problems and inconsistencies. And in 1543, there was a book that was published after his death called On the Revolutions of the Heavenly Spheres, where he talked about a solar system, something that was never heard of before. But he made it perfectly clear. Now, here's a picture artist rendition of Copernicus. Not a lot to be interpreted from the photograph other than that he's praying before Jesus. And we see this in the photograph. Of course, then again at the bottom you see there's a skull there. So it's kind of the mortality of man as it applies to science. Now, there was a gentleman by the name of Tycho Brahe. and he was Johannes Kepler's assistant. Johannes Kepler was um, basically another philosopher, and Brahe just carried on what he had. He was a champion of observation. You see, now in science, there's observation. We observe things, and we make notes. He observed the appearance of a new star, a nova, in 1572, and he later built his own observatory, which was really kind of unique. Because, like I said, they were getting in back in those days in scientific revolution. They were getting into optics. What does the eye see? How does it register it to the brain? Um, Tycho was not a Copernican. Planets orbited the sun, the whole of which orbited a stationary Earth. So the sun and the Earth were stationary. He was the court astronomer to Rudolf II in Prague, and Johannes Kepler, who was was Tycho's assistant. I got it a little mixed up there. Johannes Kepler was Tycho's assistant. Everything had been created according to mathematical laws. Make sure you write this down, because everything is according to science, and mathematics was the language of God. In mathematics, there was perfection and musical harmonies. Well, if you look at music, it's based upon numbers and mathematics, you see. And it was very ingenious what Kepler came up with, because now mathematics was going to become somewhat, you had to learn it in order to understand everything else. Now, Kepler believed there were three laws of planetary motion. The planets travel in elliptical orbits, in a circle. The speed of the planets vary with their distance from the sun. And magnetic forces keep the planets in orbital motion. Now, we won't see anything about gravitational pull until we get to Isaac Newton. But Kepler and Tycho Brahe were very instrumental in understanding that the universe didn't work the way we always thought it did, as how we were taught through religion. He wrote a few books called Cosmographic Mystery, New Astronomy of Celestial Physics, and The Harmonies of the World. And I broke down the distinctions between the heavens and the earth. Again, science is going to have somewhat of a conflict with this. Now, here is a rendition of Brahe studying the planets and gravitational pull and things of that nature. And like I said, we're just going to go over the highlights. Excuse me. New Heavens, New Earth, and Worldly Politics, Galileo Galilei, 1564 to 1642. What was Galileo the man really like? Well, he was very witty, and he was a persuasive writer. He wrote in two languages, Latin and Italian. He was a popularizer of the non-Aristotelian approach to science. And what does that mean? That'll be explained a little bit later. And he was opposed. He had a lot of impatience when for those who opposed him. Well, you know, that's kind of not the staple of debate, really. You have to have an opposing viewpoint in order to come to some sort of understanding. It was a new relationship between religion and science, and the controversy actually evolved into a collision course with the church. So Galileo was actually one of the first scientists to have a problem with the church. He built his first telescope in 1610, which had never been done before, and observed the features of the moons of Jupiter and sunspots, and he challenged heavenly perfection. That's why he was basically not in favor with the Catholic Church. He wrote a book in 1610 called The Starry Messenger. Now, he was later called before the church courts, and he needed a patron, somebody who disliked the power of university authorities because universities were not going to change their mode of thinking. He turned to princely courts and took a position as a tutor to the Medicis because back then scientists that really didn't get paid anything to study. In later years, there was a conflict with the church. A Dominican monk denounced Galileo's ideas as a dangerous deviation. Of course it did, because the church wanted to maintain control. And if they maintained control, that means that anything that got in their way was dangerous. He wrote a letter to the Grand Duchess Christina de' Medici in 1615, and one can be sincere Copernican and a Catholic. You can believe in both things. Understanding the physical world is best left to the natural philosopher. Okay. In 1616, there was an Inquisition. Now I don't know if we didn't cover this in the last chapter, but in World History 1, we talk about the Spanish Inquisition that used to torture people until they converted. Copernicus wrote De Revolutionibus, and it's placed in the index of forbidden books because what happens if you have science that contradicts God's word? It's very dangerous to the church. Here's a, a artist rendition, a portrait of Copernicus testifying before the Inquisition. And you know, when you bucked the church back then, they really got angry because the church meant power. They had a lot. The church had a lot of power. In 1632, he wrote a dialogue concerning the two chief world systems. The Inquisition banned the book. Galileo was ordered to stand trial in 1633. He recanted his beliefs and was placed under house arrest for life. So, if you disagree with the church, back then that's what happened. Instead of having an open mind, they believed that the church ruled everything. Um, his legacy, the theory of inertia, okay, the law of falling bodies, which had to do with both the theory of inertia and the law of falling bodies, had to do with gravity. He wrote the two new sciences in 1638, and he combined discovery, observation, experiment, and mathematics. Remember, mathematics are very important. There's a lot of people out there that can't stand math. It's not that I can't stand it. Sometimes I just don't understand it. Okay, now we're going to talk about Francis Bacon. Francis Bacon expressed the need for scientific method. That's experiment. You form a hypothesis, and then you do an experiment. You record your observations, and then you do the experiment. You have the control, and then you record your conclusions to see if your hypothesis was correct. This is new evidence in the potential of human thought. Now, how is that uh, the standing for the potential of human thought? Well, it goes beyond the boundaries of normal thinking. You see, when you have to actually think about something, you add to the literature, you add to the knowledge, and that's what Bacon believed. Francis Bacon was the Lord Chancellor to James the First. He developed a theory between the contradiction between the ancients and the moderns, and there was a separation of scientific investigation from philosophical argument. When you can't actually make a scientific argument, you have to be philosophical about it. And Bacon didn't exactly appreciate that. He wrote this book, the Verulimus Rumus Novium Orgarum, in 1620, and he didn't really have a lot of conflict with the church. He invented the inductive method. Now, what the inductive method is, it combines the evidence from observations and you draw general conclusions. Deductive method means you eliminate things. Basically, that's what detectives do. They deduce, a deductive method. Bacon also believed that there should be a cooperation between researchers, because if you share your research, then you come up with a larger body to use. And it was useful knowledge. Everything's useful knowledge. When you get people together researching the same topic, they may have breakthroughs and they need to communicate. He wrote another book called The Great Instauration and The New Atlantis in 1626. Very prolific type of scientist. Now, Bacon believed that the universe was heliocentric, and he talked about heliocentricity. He also believed in the mathematical physics and the new method of inquiry, science as a distinctive branch of knowledge. Before, science was just part of religion, and the natural philosophy, the philosophy of life. René Descartes, from 1596 to 1650, he was French. He was an intellectually restless man. He began working on essays on optics, geometry, and meteorology, and he had a systematic doubt of everything. Now, what does that do? Well, when you have a systematic doubt of everything, it makes you want to research things to look for solutions to particular scientific problems. Cogito ergo sum. I think, therefore I am. The thinking person exists, reason exists, and God exists. So this is a little bit different from, going up against the Catholic Church. All right. This was an original drawing that he made in 1729. Excuse me, I'm a little stuffy. Bacon had the inductive method, whereas Descartes had the deductive method, which I explained before. A fresh start for knowledge proceeds logically from one certainty to another. Mathematical thought is an expression of the highest standards of reason. Of course it is. You need a lot of brain power to do complex mathematical problems, and that's what Descartes advocated, was we need to be a little bit, have a fresh start for knowledge. And mathematics ruled the day. Mathematics is a part of everything. Science, physics, actually, it's also part of history. And I'll explain that at a later date if you remember to ask me. He came up with a mechanical philosophy that nature was a machine, and that he rejected the medieval distinction between the works of man and those of nature. Even though Roman Catholic Church believed that if you have works by man, they are works of nature because they are God inspired. And he moved toward a new conception of matter. Ooh, that's going to be tough. And nature and natural laws. Now that would become important later when we start talking about politics and we get to the Enlightenment. We start talking about people like John Locke and Baron de Montesquieu and Jean-Jacques Rousseau. The Cartesians were mostly French and Dutch from Holland. They believed in mathematics and logic. Blaise Pascal from 1623 to 1662, the probability theory, that the probability that certain things would actually occur. That's a scientific, philosophical type of theory. Pascal also believed in theology, the study of religion as well. So now we have a little pour over, we have a little overhang that the religion and science together. Christian Huygens, from 1629 to 1695, he tried to resolve the problem of impact, why planets aren't slamming into each other in orbital motion. Baruch Spinoza applied geometry to ethics. A little difficult to understand, but you can see how mathematics is starting to play a big part in this scientific revolution. The Baconians, on the other hand, began with practical research and sought empirical laws based on evidence, which means that certain things happen because there's a law to it. There's a scientific law. William Harvey, from 1578 to 1657, started to study anatomy, the human anatomy, dissection, circulation of the blood, and dissection of animals. Now, Leonardo da Vinci did this during the, excuse me, during the Renaissance, when he started to cut open horses and vivisection. Now, vivisection was against the church because you were desecrating a dead body according to the church, but Leonardo da Vinci did it for the sake of knowledge. And William Harvey was one of these people, but he followed in da Vinci's footsteps, but he didn't dissect humans. Robert Boyle came up with Boyle's Law. You can read about that in your textbook. And Robert Hooke, from 1635 to 1703, introduced the microscope, which was going to be very important when identifying organisms and how they work, and the cellular structure of plants to determine how things grow. God, according to the Baconians, was a clockmaker. Science and society and the state all operated under his guidance. The Royal Society was organized in 1662, and this was in England, and it was committed to experiment and collaborative work and served both political and intellectual purposes. And there was a common sense of purpose, why they existed. The Royal Society was dedicated to scientific exploration and scientific inquiry at the time. And in fact, one of its later members was Benjamin Franklin. Philosophical transactions. Let's sit down and talk. What are your thoughts about why life exists? It reached out to professional scholars all across Europe. The French Academy of Sciences was organized after that, and there was a state-sponsored framework for scientific endeavor. The power of method and the force of curiosity in 17th century experimenters. Now, easing the exchange of information and theories. That's how, like I said, we come to better conclusions. Margaret Cavendish was a woman in science, and Maria Winkelmann was in science, and they were refused admission to the Berlin Academy of Science because specifically they were women. There was also Maria Sibylla Merian, who studied entomology, which is the study, I believe, of insects. This is the French Royal Academy of Arts and Academy of Arts and Sciences in 1667. And then we have Isaac Newton, and all was light. Isaac Newton lived from 1643 to 1727. Newton, the man, was born to a family of small landowners. He studied at Trinity College in Cambridge, which still exists today. He stayed 35 years. He was reclusive, secretive, and an obsessive man. Uh, Newton, the scientist, believed in optics. He used prisms to demonstrate that light was composed of different colored rays. If you look through a prism, you can see different colors. Mathematics, he was formulated integral and differential calculus. So if you take calculus, you owe your reason of sitting in class to Isaac Newton. And gravity, the falling apple, that was very important to understand the falling apple, because every action has an equal reaction, and this is Newton experimenting with light. Okay, Newton worked on the reflective telescope, and he was elected to the Royal Society in 1672. And his primary integral work was called Principia Mathematica, Mathematical Principles of Natural Philosophy. It was published in 1687, and it was a long and difficult work. Anything on mathematics is going to be long and difficult, but it's because of Newton that we understand it and we know how to explain mathematics. Newton hypothesized and theorized that gravitation was a universal force that could be expressed mathematically. Of course, we know that. He built on the work of Galileo, Kepler, Boyle, Descartes, and Hooke that we talked about earlier, a single descriptive account of mass and motion, and he wrote the laws of gravitation. Now let me pop out a second here so we can read this. He wrote the General Scholium, and he answered the objections to the Principia, which would basically make the Principia a perfect type of manuscript. Remember, Newton was obsessed. He was very obsessive. Newton's legacy was that certainty and objectivity lay in the precise mathematical characterization of phenomena. Anything that occurred concerning gravity had a mathematical formula to it. And over the years, we've seen this is true, like the theory of relativity by Albert Einstein, E equals mc squared. He was popularized by John Locke, who was a political type of commentator. He wrote about natural laws, and he also stated in one of his books that I have here, it's called the Second Treatise of Government, that man was given natural inalienable rights, and among these natural inalienable rights granted by God are life, liberty, and the pursuit of property. Well, the founding fathers used this in the Declaration of Independence, life, liberty, and pursuit of happiness. It had to be changed. He's buried at Westminster Abbey, and Voltaire, who was a philosophe, which we're going to talk about later, a French philosopher, spread Newtonian ideas to France. Now, we already talked about that. Reform of government. Okay, so now what's going on is political thinkers are starting to use scientific methods to increase the reform of government, reorder society, and purify religion. Purifying religion by getting the bad people out or getting the bad ideas out. And that was another goal for them. Transformation in science and cultural change. Science had to be brought into the current century, the 17th and 18th century. Science is a justification for Western expansion of an empire. That's political, it's cultural as well. And science and elite knowledge, observations had to be made in order to determine what impact science would have. And the authority of the ancients did not disappear quickly. So what we're seeing is this scientific knowledge goes into cultural change. How do we do that? Science did not subvert religion. It was actually two different beliefs. But there's always that type of fight over creationism and evolution. where God created man, but evolution demonstrates that man was here a lot longer before the Bible actually states. There's always going to be that conflict. Newton was a transitional figure between the past and the future, and he provided new answers to fundamental questions. Now, what we see in science and cultural change is the scientific institutions are now instituted so people can study it. And what is the purpose of and practice of science? Is it to prove certain things correct, prove certain things wrong, how things exist? And mathematics played a big part, always played a big part in science. So what we have is the scientific revolution, and we look toward how different things change throughout history. The scientific revolution opened up a lot of doors for scientists in order to understand how the universe worked. So that is the end of chapter 16. I would urge you to read the chapter because Thursday we're not going to be covering it. We're going to be starting on chapter 17, I believe, if I'm not mistaken. And if I am, I apologize. And the rain's making me a little sleepy and a little less cognitive today. So what I'm going to do is I'm going to leave you now. Please be safe, and hopefully we'll see each other Thursday, and we will start the new chapter, which I believe is on the Enlightenment, which is always interesting because we get our different types of thinking about government from the Enlightenment and how people should be treated. So I will see you at school, hopefully. And if you have any questions about the scientific revolution, please contact me through email or through Canvas. Okay, but everybody be safe, and I'll see you Thursday.